Good morning, grade sixes, and welcome to another natural science lesson with me, Miss Kun. This lesson is brought to you by WorksheetCloud, and remember that if you've got any questions, please take a note of them, write them down, and email your questions to grade6@worksheetcloud.com. I hope that you had a wonderful day yesterday and you learned lots and you still remember what we spoke about because we are going to go through some of the terminology and some of the words and things that we learned yesterday in today's lesson. So let's get started. So today we are going to continue with our lessons on solutions, but today we are looking at part 2. Yesterday we did part 1 and today we are looking at part 2, and I think you might enjoy it because we've got something cool at the end which I'm sure you'll enjoy. So let's get started. So to just look at our lesson objectives today, we are going to start off with terminology because, like I mentioned yesterday, I talk science all the time, and the only way you're going to be confident and comfortable in all the various different words that you learn is that you talk all the time and you use them as you're describing something and as you're explaining something. So it is important that we go through that terminology. Today we are looking at what is a saturated solution and what this word means when we describe a solution as being saturated. We are then going to look at making sugar crystals, which is going to be a really cool project that you can do at home. We're going to look at crystals in nature, and then we are going to end off today's lesson with a fun quiz. Okay, let's get started. So I'm going to go through some of the words and the terminology that we learned yesterday, as well as I'm going to bring up some new words that we're going to learn today that is going to appear throughout the lesson. So the very first word, which I'm sure you've all seen before, is the word mixture. Remember that the word mixture means two or more substances that are mixed together, but they are not chemically joined. So that is a very important sort of differentiation between the word mixture and solution, because in a solution where a solute is soluble, you don't see the solute anymore because it is now chemically joined with the solvent to form a solution. Right? Moving on to the word solute. Remember, a solute is a solid that dissolves in a solvent to make a solution. Most of the time it is a solid, but you can also get a solute that is a liquid as well, just like my Oros in water example. Then we have the solution, where it is a mixture made when a solute dissolves inside a solvent. You can't see the solute anymore, and we have a solution. Moving on, a solvent is the liquid in which the solid dissolves to make a solution. Remember, a solute plus a solvent equals a solution. Remember that little equation from yesterday? If not, remember, all the lessons are on WorksheetCloud, so you can go back, you can watch them 100 times if need be. They're all there for you, plus all the activities as well. Right, moving on. Soluble. Remember yesterday we also spoke about soluble and insoluble substances. The word soluble means a substance that can dissolve in a solvent. We talk about when a solute is either soluble, which it can either dissolve, or it is insoluble, where it cannot dissolve. If we look at the word solubility, solubility means a measure of how much solute can dissolve in a solvent at a given temperature. So when we look at the solubility of certain substances, it's how much that solute can dissolve until it can't dissolve anymore. And that will bring us to saturation, which we're going to talk about in a little bit. Dissolving is mixing of a solid with a liquid to make a solution. So I have spoken about the word dissolving before, when we mix a solute with a solvent and we see that the solute is dissolving. Remember, it doesn't disappear at all. It's not like magic, like I mentioned yesterday, but it dissolves and the particles are then dispersed. The particles of the solute are then dispersed within the solvent, and together now it forms this new mixture, which is a solution. And today we are going to look at the word saturated, and what that means is a solution containing the maximum amount of solute that it can hold. Remember that in a solvent, the solvent has got its own particles, and so the more the solute is dissolved, and now the particles are now mixing and it's dispersed amongst the solvent, there's only so much that solvent can hold, and eventually it can't hold anymore, and so that solution becomes saturated. So that is what we're going to be doing today. I just want to go back in a little bit more detail and revise again what the word solution means. So solution means a mixture in which one substance is evenly distributed throughout another substance. I wanted to go through this term again to bring up these two words, evenly distributed. It is very important when we describe a solution, because as you can see here in this particular picture, the solute is dissolved in a solvent, and you can see the particles are evenly distributed, and that's when we have a plain solution. So when you get a question where it says, what is a solution, or explain what is a solution, describe the components of a solution, always remember to mention that it's when a solute dissolves in a solvent and the particles of the solute is evenly distributed throughout the solvent, and together it forms a solution. Right, so now that you know what a solution and evenly distributed, that brings us to a saturated solution. Now, if we have a look at the question, what is a saturated solution? So a solution can be described as being saturated. And when we describe a solution as being saturated, it means that no more solute can dissolve in the solvent. That solvent is now full of solute. It's like it's heavy. It can't dissolve any more solute because there's already so much of the solute that is dispersed within the solvent. So what happens? What happens is that you'll see there at the bottom of this particular beaker is that you have your remaining solute that cannot dissolve anymore, and we call this a saturated solution. When it reaches this point where the solute can no longer dissolve, we then say it has reached the saturation point, and now we have a saturated solution. Right, now just to explain that a little bit better, again, I've got my trusty glass of water. I do want you to just picture that I'm in a very fancy lab or a lab at school, and I've got very cool equipment around me, but because I'm at home during the lockdown, like all of you, I'm just going to make use of things that I've got around the house. So I've just got a glass of water, and I have got sugar, teaspoons of sugar next to me. And what I'm going to do is that I'm going to add sugar 1 teaspoon at a time. I'm going to stir my water, which is my solvent. I'm going to stir my solvent. And every time I add a teaspoon of sugar, which is my solute, and I've stirred it and it should dissolve, remember that we're going to just have a look and see what happens, and I'm going to carry on adding sugar until the sugar no longer dissolves. So let's go. 1 teaspoon of sugar. Okay. Stir. Already I can see it starting to dissolve. You have to give it a little bit of a mix. In our lesson on Monday, I'm going to talk about dissolving and the rates of dissolving and factors that affect dissolving. So we'll talk about that on Monday. Right, 1 teaspoon down. Let's add another teaspoon. 2nd teaspoon. We can see that our solvent can still hold some solute. Already we do have a solution because the particles of the solute are evenly dispersed throughout my solvent. Remember, evenly dispersed. Keywords, talk science all the time. Giving it a little bit of a mix. And again, I can add a 1/3 teaspoon. Giving it another bit of a stir. Don't mind me as I'm sitting here stirring my solution. Okay, what I'm starting to find is that the solute is starting to gather at the bottom of my solution. Let me add another teaspoon, very slightly. Give it a bit of a mix. I think we should have reached a saturation point at this stage. Right, I want to turn, I'm going to bring this quite close so that you can see. I don't know if you can see, but at the bottom of my solution, I do have some solute that is left over. My solution, I can say right now, is a saturated solution. The solute particles, they are dispersed within the solvent, but the solvent now is too heavy. It cannot hold any more solute, and so the sugar can't dissolve anymore. At this point, it's reached saturation point. We now have a saturated solution. Saturated solution. Right. Now, I am going to introduce you to a really cool activity. This is something that you can do at home, and this incorporates all the concepts that we are busy learning in science. So if you can, I'm going to explain how to make your very own sugar crystals. For those of you that like to eat sugar or would like an activity to do. So this is something really cool. So the materials that you're going to need 2 cups of hot water. You're going to need 4 to 5 cups of sugar. So this does take a bit of sugar. You can use different food coloring, because with the crystals, depending on the food coloring, it'll come out as different colored crystals. You're going to need a piece of string, and you can also use a sort of a dowel stick, a little stick, that as well. And I'll show you in the next slide a picture. You're going to need a pencil or something to hold the string if you're going to use string. And I forgot to put you in my materials that obviously you need a jar to contain all of this. Right, let's look at the method. So step 1, you're going to add the sugar to the hot water. Right, and you need to stir it. Add the sugar. I would say start off with about 2 cups, stir it, make sure that it has dissolved. You don't see any sugar left over there in your hot water. Then you add another cup, and you should add to 2 cups of water between 4 to 5 cups. It also depends on how sweet you like certain things. Then step number 3, you're going to add a drop of food coloring. So you can see in this picture they've made 3 different solutions with different colored food coloring. So maybe you want to make one red, one green, one blue. You don't need food coloring if you don't have food coloring. It just makes the crystals really cool. Then you're going to tie a piece of string to the middle of a pencil. You are then going to, with your pencil and your piece of string, you actually want to have a starting point of this crystal. So I want you to just wet the piece of string a little bit on the end and just roll it around in some of the sugar and let that dry until it gets a little bit hard. Once it gets a little bit hard, then we are going to, if that string is ready to go and be placed into our jar. Then we place the pencil at the top with the string and let the string hang into the solution. Now I've got this beautiful solution in my jar, this whatever color it is, this your sugar solution. And it's important that your piece of string doesn't touch the sides or the bottom of your jar. So make sure that that piece of string is suspended inside your jar. Remember we looked at the word suspended particles yesterday when we looked at insoluble substances. Right, and then all you need to do, put it somewhere, leave it for a week, and then watch your crystals grow. So this is what should happen. So your crystals are going to grow. They're going to look something like this. Here is a picture of your sugar crystals growing on a piece of string. It should look something like that. Or as I mentioned earlier, if you want a stick, you can hold a stick, and instead of a pencil with your string, you can get a peg to hold your stick in place. Make sure that your stick again is not touching the bottom or the sides of your jar, and within a week you should start to see these sugar crystals grow, and then you can eat them and enjoy. So just a really cool activity that you can do at home. It does incorporate the theory of solute solvent solutions, and I'm sure it's something that you will enjoy. Right, I want to now talk about where we actually find crystals in nature. So in caves, now have a look at these pictures of caves. Don't they look absolutely amazing? Firstly, they're huge. Here's a picture of a man standing in a cave. Now, if you have a look at these pictures, you see all these sort of sharp points from the bottom and at the top. Now, these points, these sort of columns, if we call them columns, are actually, there's two names to these columns. The top columns, these ones that we see at the top, are actually called stalactites, and the bottom columns are called stalagmites. Now how this forms in nature and how caves are formed, and it takes a very, very long time, years and years and years. So what happens is that the limestone in rock, when water passes through the ground and through these caves, the water that passes through the ground starts to sort of drip into the caves. And what's important is that in the water, there's the limestone that has dissolved from the rocks, then drip in the water into the caves. And what you find is that once this water is either dripping from the top and then it's dripping at the bottom, these two columns, when the water then evaporates, what is left over is the limestone or the salts and those crystals from the lime that then start to form these two sort of points, these columns. So at the top we call them stalactites, where it drips, and then as it drips, it starts to form, and it almost looks like an ant's nest. Have you seen those sort of termite mounds almost? These termite mounds that they form and they go up like that. So in nature, we find crystals in nature, and this is just one example of stalactites and stalagmites, and it's when limestone is dissolved and when the water evaporates, and what's left are these crystals, these beautiful crystals, just like your crystals that you're going to make with your sugar. These crystals are left behind from the evaporation of water, and we have these beautiful sort of columns that we find in caves all over the world. So it's just an interesting fact. It's really cool. You can read up more about crystals in nature. You can read up more about stalactites and stalagmites. It's always cool to continually question the world around you, ask questions. How does this happen? Why does this happen? When does this happen? You're all little scientists, and this is how we learn, we explore, we create and design experiments to find certain answers if we don't know the answers. And I'm sure some of you are sitting at home and you are going to be in labs one day and doing all kinds of experiments and things. Okay, now we have reached that part of the lesson where we are going to have a quiz. So, are you ready? I think possibly, if you would like, get a piece of paper and a pencil to do this quiz. If you don't have a piece of paper or a pencil, that's okay. We are taking it question by question, and I'll give you a little bit of time, or if you do need longer, then you just pause the video, which is great, and then you wait for me to give you your answer. Are you ready? Do you have your thinking caps on? Okay, let's go. Question number 1. As temperature increases, most solids increase in solubility. So this is a true or false question. Let's look at this question again. As the temperature increases, most solids increase in solubility. Now, if I unpack that, that is saying that if I have to heat this mixture and I add heat to this particular mixture, the solid which is my solute, which is my sugar in my solution at the moment, it's going to become more soluble and it is going to dissolve. Remember, a substance is soluble when it can dissolve. So is this statement true or false? Have a think. Did you say true? Congratulations. Right, good. Moving on to question number 2. It says, a saturated solution can be made unsaturated by heating the solution. So it just turns out that I have a saturated solution right here. So if I have to apply heat to this saturated solution, it can become unsaturated, and the leftover solutes that hasn't been able to dissolve will eventually dissolve by that addition of heat. Do you think that is true, or do you think that is false? What do you think? It is true. Yes, it is 100% true. Your solution, a saturated solution, can be made unsaturated if you apply heat. And we will look in more detail with that in our next lesson on Monday. Question number 3. A substance is what if it dissolves in another substance? So this is a term question. Fill in the term. Is the word, we've got the words insoluble, soluble, saturation, solution. Which term can I plug into that sentence? Again, a substance is what? If it dissolves in another substance, you guessed it, it is soluble. A substance is soluble if it can dissolve. Good job. Question number 4. We have another term question. What is a mixture in which one substance is evenly distributed in another substance? My terms again are insoluble, soluble, saturation, and solution. I'll read it again. A what is a mixture in which one substance is evenly distributed in another substance? What is my term? Correct again, solution. A solution is a mixture in which one substance is evenly distributed in another substance. Question number 5. A solution is what? When extra solute is at the bottom of the solution. Do we say insoluble, soluble, saturated, or solution? You guessed it again, the word is saturated. A solution is saturated when extra solute is at the bottom of the solution. You're doing so good. Well done. Okay, let's continue. Question number 6. Now this again is a true or false question. The substance that is present in the greatest quantity in a solution is called the solute. Those of you that remember from yesterday's lesson, what do you think? Is it called a solute? Yes or no? Nope, unfortunately not. It is not called the solute. Remember that the substance that is present in the greatest quantity is known as the solvent. The substance in the smaller quantity is the solute. So it's smaller, solute, smaller. Question number 7. True or false? Sterling silver is made up of 92.5% silver and 7.5% copper. The silver would then be classified as the solute. So look at those percentages again, 92.5 and 7.5. Is this 92.5, would that be classified as the solute? No. False. It would not, because remember that in this particular mixture, 92.5 is the greater amount, so it would be classified as the solvent, and the copper would be classified as the solute. Right, boys and girls, that brings me to the end of our lesson for today. I hope that you've enjoyed Solutions Part 2. Remember, if you've got any questions, email your questions to grade6@worksheetcloud.com. It has been a wonderful day. I hope that you've learned lots and you remember your terminology. Remember to continually talk science. Have a wonderful, wonderful weekend. From me, Miss Kun, a very hakuna matata. Be kind to one another. Bye.